Our motto is bridging science to practice. So we are not particularly a university, but nor are we a industry or consultancy. We're somewhere in the middle where we try to bridge science to practice. We have about 180 or so researchers, and we do research covering the full water cycle. And hydroinformatics, digitalization, digital water, the use of AI is also a key topic for us in our institute, where we're also testing and developing solutions that can be of use for the water sector, particularly to address emerging challenges that we have. KWR started off as well, for the ones who are in the Netherlands, you would know of Kiva. So we were actually associated with Kiva, which was the, let's say, the regulation institute of the Netherlands. But during the 70s, we became an independent water research institute, or a department of Kiva, rather. And then very recently, now we're a research institute working very closely with the drinking water sector of the Netherlands. But coming to our topic, we are living in an unprecedented time, right? We have a lot of information now available in the, if you look at the history of our, let's say, our mankind or humankind, 90% of the data that we have actually almost collected has been only in the last few years. So it's been quite a accelerating rate where data is now available for us to really do something with it. And that's also, of course, having an effect in our industry, in the water sector as well. And that's really made possible because of new technologies such as IoT-based sensors and very advanced monitoring systems that we have. I'm not going to go into too much detail on that because I think there's a couple of very good experts and actually technology providers who are going to follow me, who will do a much better job than I will. But the fact that we have so much data available is really giving us the opportunity to also utilize new and enabling technologies, particularly to address the challenges that we face in our sector, which is quite prominent and also has a wide, let's say, effect to our population. So AI, can it be something that will come to the rescue, and how straightforward is it? Huh? That's the true question that we have. It has shown a lot of, let's say, promises, of course, in other sectors. We see it in the news all the time. But the water sector is a very unique sector as well, where we have a lot of challenges, perhaps not so much data yet, and also very complex, let's say, systems. So how much can AI play a role in help us be able to, let's say, come to certain solutions that can help to ensure that we are resilient in the future with respect to our water availability and our water quality. Um, so what does that really mean for the water sector? And there's some, let's say, opening, let's say, examples that I also have, but we will be followed with much nicer ones perhaps after me in that sense. But let's start triggering our thinking about where AI can be of use and also be a bit critical at the same time in the role it can play for our solutions. But really, it comes down to making decisions with your data, right? And AI is allowing us, it's perhaps a tool that can be utilized for that. So we are been collecting data, well, more recently, much more, as I mentioned, but we've been doing that for many years through laboratory measurements and so on. And what we do with the data is some kind of process modeling or some kind of representation of our systems, right? The use of data to analyze it and also be able to do some kind of modeling with it. And we visualize these results, and that somehow allows us to do some decision support. So really, the role of AI in that sense is, in many ways, I would still argue not to replace us, particularly in the water sector, but really be able to enhance our understanding of our systems and also enable us to make good decisions with it. And sometimes also the decision support can allow you to also understand what further data that you need to, let's say, collect. And that's really important to have this feedback because your AI systems are only as good as your data. So really having this feedback loop is very, very important in that sense. So some examples in terms of where AI plays a role in the water sector, and this is certainly not an exhaustive list. This is what I think is very prominent, but I'm sure there's much more that I've missed out. But the use of AI comes into really understanding our systems better because of how complex and dynamic they are. for example, using unsupervised learning methods such as clustering and dimensionality reduction and so on, where you can really fuse different heterogeneous data to make more sense out of your systems. The use of neural networks is, of course, prominent. Dense neural networks, deep learning models, where you can predict and forecast your systems much more to try and look more into the future and make some preemptive, let's say, decision making or operational changes to your systems to be able to avoid certain challenges that you would have. Optimization, use of reinforcement learning, for example, predictive maintenance, which I think is also a topic for some of the presentations after me, but also identifying anomalies in your systems, whether that's from the data itself, from sensors, because data quality is, of course, a big challenge, but also in general deviations in your systems that you should not be, let's say, you don't want to have to you, because you want to run a more stable system as possible. And of course, the hype that has been going on for a couple of years is the large language models, and that's also being quite prominent in the water sector as well, where we can use LLMs or LLM type technologies to manage our knowledge better because of the wide spectrum of knowledge that is there and so heterogeneous between people and organizations. But also help with chatbots and custom interactions. And also development of scenarios because LLMs are quite strong in actually developing and thinking, let's say, augmenting the thinking of humans. So you can actually utilize LLMs to create scenarios where you can use that data as input for your further modeling practices as well. Uh, in some things that we do in KWR, and what's also very prominent is the use of AI for in chemistry, for example. And this is since water quality is a topic also for the Upwater program, I thought it would be an interesting one to discuss, where microplastics is a great is a big challenge that we face in our let's say our open water systems and how computer vision, for example, where you collect data from laboratory-based measurements, such as spectral-based measurements that you do, can be utilized, processed a bit, and also allow us to identify other compounds of microplastics based on what has been learned with this data and this, let's say, image-based data to try and let's say predict and identify more microplastics in our system. So this is something that has been quite interestingly developed in the past couple of years. And something to look more into the future where we would like to be more flexible and resilient, particularly with our distribution networks, because the designing of our, let's say, our pipe systems and so on, are traditionally been a bit more deterministic, where we really look into one, let's say, future scenario, and we try to design for that. But how can we consider that to be more flexible? Because we have more complexity in our systems, we are facing more complex challenges. So the use of AI and also very specifically reinforcement learning, where you can have agent-based learning to adapt to solutions in the to changing environments. So that could be environmental conditions, but also population shifts and so on and so forth. And I mean, people, not microbiology for the microbiologists here, in that sense, can be also what is a very interesting field that is being administered right now to really think for the next 30, 50 years and the use of AI for it. And also, when it comes to sustainability, particularly in the water sector, and I'm looking more specifically in wastewater treatment here, where greenhouse gas emissions is a big challenge, of course, and we would like to reduce it as much as possible. And nitrous oxide, which is lachgas in Dutch, is a prominent wastewater greenhouse gas that has been emitted also in the treatment plants treating wastewater, and how AI can be of use to that, where we can forecast nitrous oxide emissions, but also feed control model predictive control and advanced process control systems to try and reduce these emissions. This is also something that is being done in KWR, but also in other utilities such as Waternet, I think for life and failure, as I see someone over there. So has been also been utilized for that in this sense. But the thing is, AI tends to be quite the source of hype as well, right? We see a lot of that coming up, particularly with the LLM phase that we see. So really, there's a cycle of the hype cycle of AI that we really need to think of also for the water sector, and that's why I say we need to be as critical as we can when we think of the use of AI, particularly for our, let's say, critical infrastructure that we have also in the water sector. As you can see in the chart over here, ChatGPT really was the innovation trigger that really led to this boom of use of LLMs. And we really, there's been a lot of, let's say, peak of utilizing of ChatGPT and also different technologies that have come up in that. But that is also can lead to, let's say, this thought of disillusionment. Sorry, that's a tough word for me. Where we really feel like AI can solve everything, and that perhaps is something that we need to really think about a little bit more and understand what are the, let's say, the roadblocks and the challenges, and also the limitations of using of AI, and think of how the redesigning of our products where AI is used can actually be of use to our systems as well, and that could really lead to some kind of productivity in that sense. So this is also something that I think we will face in the AI in the water sector as well, where we believe AI can be of use for everything, but we need to really think together where it is of use and where it is not yet of use. But something that is, let's say, been a prominent, let's say, feel also with the, let's say, in the combination of domain knowledge and AI, also in the water sector, but also in other sectors as well, such as material science and so on, is the development of hybrid models, or what we call physics enhanced machine learning or chemical enhanced machine learning, where you can really combine the decades of experience that you have in the domain also with AI. And this is a very new, promising field that is coming up. Um, the idea is that you can provide more interpretable and, let's say, generalized results with your AI. So you are really opening up the box. It's not a black box anymore, but perhaps more gray in that sense. But perhaps this is one way where we can really combine the two, let's say, schools and two ways of thinking in the water sector, and also increase our trust in the use of AI and machine learning in a rather traditional process engineering world that we work in the water sector. So this is something that is really picking up speed right now in many let's say industries, universities, and research institutes, and it'll be very interesting to see how this will also be utilized in full-scale applications as well. I think that is my last slide. So I hope Rudy is proud of me with keeping the time.
Most definitely.
Yeah. So if there's any questions, please do ask me. And if you would like to connect with me in LinkedIn, please do scan the QR code or just search me and we can connect and talk more. Thank you very much.
Excellent. Thank you very much, Sid, for this underlying overview presentation. And it's a whole new field that comes towards us, many new opportunities as well. So this was a sort of overview presentation of how AI is doing in the whole scope of water, which is quite a broad topic. And now we will dive a bit more in depth with 3 presentations by startups that want to offer solutions to the market. And maybe we can make that very interactive as well. But maybe, Sid, maybe you want to stop the slide share and then we ask people whether they have some questions to you, maybe from the speakers, maybe from the audience. Is there something you'd like to get clarified before we move on to the next 10-minute presentation? Anyone having a question for Sid? And if not, I do have a question. As you work at Helene is raising her hand. Go ahead.
Okay, thank you. Sid, thank you for your presentation. I thought that in the beginning you said that within the water sector, we do not have that many data yet. And well, I'm already working for many years in the water sector, and I always have the feeling that there is an enormous amount of data in the water sector, because if you look at drinking water companies, they measure the quality in the distribution network, at customers at home, at the treatment plants, the same for the water boards. So I have the feeling there is an enormous mountain of data, and that in fact the companies should use it much better. How do you see that?
Yeah, you're right, Helen. It's not black and white. Indeed, there is enough data. There is a lot of data. Let's put it that way. In the water sector, how much usable data is a different story. I think once you really start doing the validation checks and quality checks, that is going to be a big hit in how much data we have. But if you still compare the amount of data that we are, let's say, producing compared to, for example, what the data Google uses to train their models. I think there's still some ways to go. But of course, it depends on the process we're looking at. If we're looking at, let's say, new challenges such as PFAS, OMPs, or nitrous oxide emissions, we still have some ways to go because that's more, let's say, newer, let's say, monitoring systems that we have. But really, the traditional, let's say, systems that we're monitoring, indeed, we have much more data to already start working with solutions of AI. Yeah, you're right. Yeah, I would.
Okay.
Thanks for
And
keeping me in line.
okay,
Yeah,
and
yeah,
maybe I have a follow-up question, if that's allowed, Rudy.
Go ahead.
Yeah, because had the data available, could that data then maybe be used for what we expect? I think in the water sector is that a shortage of employees in the future. I mean,
yeah,
technically skilled people.
yeah,
So, and in that sense, if you also look at a water treatment plant, there are
yeah,
operators over there, and maybe it's difficult to find new people there, and then that the whole automatization will take
yeah,
place, maybe based on all the data already available about
yeah,
how a treatment plant performs.
yeah. Yeah, indeed. I think that's where the last slide I mentioned about the hybrid models really comes into
Okay.
play there, because well, some people call it the silver tsunami in the Netherlands, where we have a lot of people going to pension, and we're losing a
Thank
lot
you.
of knowledge.
The
I'm
silver
getting there too very
tsunami.
slowly.
Wow.
Yeah, but
Never heard of
indeed,
that before.
returning the knowledge of let's say very knowledgeable people in the sector is very important, and the digital transformation journey that we're going through in general is about that. So not just about the use of AI, but in general going automizing and going digital is it. But certainly retaining that knowledge through, let's say, the domain knowledge, but leveraging that with the use of data, the combination is what we hope can keep that retention of knowledge and capacity building for the future generation of workforce in the sector. Yep.
Thank
Yeah.
you.
Yeah. Thank you, Ellen, for the questions.
Most definitely. Samira, I also saw that you were raising your digital hand.
Yeah, I just had a question on that hype diagram that you
Yep.
introduced. Where do you think we are now on that diagram? Because I heard, like in Aquatech, I heard this sentence from many people that AI is a hype, and I disagree with that. So I want to see where we are there in your opinion.
I think we are still in the increase, in my opinion. We're still in the trigger of innovation. So for us, perhaps AI in general is the innovation in the water sector. That's one way to look at it, or the technologies of it. And we are really using it more and more. There's more examples of the use of AI. But now I'm very curious. I would be the first person who's happy if we don't come down. I would, if we just keep it going up, I would be the most happy. I'm doing my PhD also using AI, so I definitely am for such technologies, and I really feel there's a lot of scope in it. But I do see a lot of utilization of AI in scenarios where perhaps it's not best suited as well because of the hype of AI. So that's where I think the critical nature of us should come into play and understand where it's of use for our systems. Yeah,
To
because we are
balance it
critical
out.
infrastructure. Yeah.
Yeah, this was the model of Gardner, if I
Yeah.
remember it correctly. And the axes were time horizontally and expectations vertically. So yeah, it cannot be going up endlessly, because then we will be over the moon and further with the expectations. But who views actually using AI already now and then in their daily routine? Just as a poll question. Yeah, I see Samira, yeah. Ronald, Rix, yeah. Cool. Yeah. ChatGPT. I used it a few days ago. I needed to have a set of networking questions for a group. Boom. I had it within 10 seconds. I sent it off to the copy shop, and it saved me so much time thinking about that, typing them. So it kind of works. Sid, thank you so much for this very first overview presentation. Please tap in if you still